Hey everyone, and welcome back to the channel. Ever wonder what's really happening when you toast a piece of bread, or when an ice cube melts in your drink? It might seem like simple, everyday stuff, but it's actually all about the amazing world of chemistry and physics. Today we are diving deep into one of the core concepts you'll encounter in 8th grade science, the great debate between physical and chemical changes. By the end of this video, you'll be able to look at the world around you and know exactly what kind of transformation is taking place. So grab your lab coat or just your curiosity and let's get started. First, let's talk about properties. Every single thing around us, from this desk to the air we breathe, has a set of characteristics we can observe. These are called properties. We can split them into two main types, physical and chemical. Physical properties are all about appearance. Think about an apple. Its physical properties would be its red color, its smooth texture, its round shape, and its mass, or how heavy it is. You can describe these things without changing the apple into something new. You're just describing what it is. Now, a physical change is when you alter one of those physical properties, but you don't actually change the fundamental substance. Let me show you. Here I have a simple piece of paper. I can describe its physical properties. It's white, it's flat, it's rectangular. Now, if I crumple it up into a ball, have I changed what it's made of? Nope. It's still paper. I've only changed its shape and size. This is a classic physical change. The form is different, but the chemical composition is exactly the same. The same thing happens when you melt an ice cube. It goes from solid ice to liquid water, but is it still HO? Absolutely. You've only changed its state of matter. So, key takeaway. A physical change alters the form or appearance, but not the chemical identity. Think melting, freezing, boiling, dissolving salt in water, or cutting something into smaller pieces. These changes are often, though not always, reversible. I could uncrumple this paper, and you can refreeze the water back into ice. Alright, let's switch gears to the more dramatic sibling, chemical changes. This is where the real transformation happens. A chemical change, also known as a chemical reaction, is a process that results in the formation of one or more brand new substances with entirely new properties. Unlike a physical change, you're not just rearranging the furniture. You're building a whole new house. The atoms that made up the original substance actually break their bonds and rearrange themselves to form something completely different. So, how can you tell if a chemical change has occurred? You need to look for the clues. These are the indicators of a chemical reaction. One of the most common signs is a change in color. Think about a banana peel turning brown or a piece of metal rusting. That color change tells you a new substance has formed. Another big clue is the production of a gas. Ever dropped an antacid tablet into water and seen it fizz? Those bubbles are carbon dioxide gas, a new substance being created right before your eyes. Another telltale sign is the production of light or heat. When you light a match, you get a flame that's light and heat being released from a chemical reaction called combustion. Sometimes you might even see a precipitate form, which is a solid that suddenly appears when you mix two liquids together. These are all smoking guns that point to a chemical change. Let's go back to our bread example. From the beginning, when you have a slice of bread, that's your starting material. You pop it in the toaster, and what comes out? Toast. It's darker, it's crispier, and it has a completely different smell and taste. You can't just untoast it back into soft bread, right? That's because you've caused a chemical reaction. The heat from the toaster caused the sugars and amino acids in the bread to rearrange and form new molecules, which is what gives toast its distinct color and flavor. You've created a new substance. That's a chemical change in action. Another fantastic example is baking a cake. You mix flour, sugar, eggs, and oil. Each of these has its own properties, but after you bake them, you have a cake, a completely new substance. You can't separate the eggs and flour back out. The heat caused chemical reactions that transformed the batter into something entirely new and delicious. Let's do a quick recap to make sure. This is all crystal clear. A physical change affects the form of a substance, not its chemical composition. Think about states of matter, like ice melting into water, or changing the shape of something, like tearing paper. The substance itself stays the same. A chemical change, on the other hand, is a chemical reaction that creates a brand new substance. You're looking for clues like a color change, gas bubbles, or the release of heat or light. Think of burning wood or a nail rusting. You start with one thing and end with something totally different. The key difference is the formation of a new substance. Physical change, no new substance. Chemical change, new substance is formed. It's that simple. Now let's test your knowledge with a few real-life examples. I'll describe a scenario, and you can pause and decide if it's a physical or chemical change. Ready? First up, dissolving sugar in your tea. Is it physical or chemical? If you said physical, you're correct. The sugar seems to disappear, but it's still there, just broken down into tiny molecules spread throughout the water. If you were to evaporate the water, you'd get the sugar crystals back. Okay, next one. A firework exploding in the sky, physical or chemical? That one is definitely chemical. The explosion is a rapid combustion reaction, producing brilliant colors, light, heat, and sound. You are creating all sorts of new chemical compounds up there. Last one, chopping vegetables for a salad, physical or chemical? Easy one, right? That's purely physical. You're just changing the size and shape of the carrots and lettuce. They are still carrots and lettuce. You're not creating a new substance until maybe you let that salad sit for a week, and then you'll definitely see some chemical changes happening. Understanding the difference between physical and chemical changes is fundamental to science. It helps us understand everything from cooking and digestion to how medicines work and how new materials are created. It's not just something you learn for a test. It's a way of seeing the incredible, constant transformations happening all around us, every single day. Look around your own home. When you boil water for pasta, that's a physical change. When you see a battery corrode, that's a chemical change. Science is everywhere. I hope this has cleared up any confusion and made the topic of physical and chemical changes a little less mysterious. It all comes down to asking one simple question: did I make something new? If the answer is no, it's physical. If the answer is yes, it's chemical. Keep that in mind, and you'll be a pro at identifying these changes in no time. Thanks so much for watching and learning with me today. If you found this video helpful, please give it a big thumbs up, and don't forget to subscribe to the channel and hit that notification bell so you don't miss our next science adventure. If you have any questions or ideas for future videos, drop them in the comments below. Keep asking questions and keep exploring. We'll see you in the next one.